Hello! Last time we talked about how to create a template engine. Now we're going to learn how to process and calculate expressions. I'm Ferenc Tolas. Let's start the lesson. Here are several simple mathematical expressions. It's easy to write a code to process and calculate them, right? You know what is common in these examples? Operators in expressions have the same precedences. But what about this expression? We have different operators with different precedences. We have opening, closing brackets. Or what about this? If this expression can be found in a template, then how we could calculate it? As a first step, we convert the expression to reverse Polish notation. This is a mathematical notation in which operators follow their operands. Instead of writing 2 plus 3, we write 2, 3, and plus. It was invented in 1924. The interesting thing is that it was reinvented in 1960 to reduce computer memory access and to utilize the stack to evaluate expressions. So let's use the shunting yard algorithm and try to produce the reverse Polish notation. So here it is, the algorithm. Let's try to read tokens from the input. So read a token. If the token is a number, then just push it to the output. If the token is a left bracket, then push it to the stack. If the token is a right bracket, then why the operator is not a left bracket, pop the operators from the stack to the output. If there are no more tokens to read, then we have to pop all operators from the stack to the output. Something is missing, right? So what happens if a token is an operator? So if there is an operator at the top of the stack with greater or equal precedence and it is left associative, and it is true that the operator at the top of the stack is not a left bracket, then we pop operators from the stack to the output and we push this new token to the stack. Sounds a bit complicated? Let's see in practice. It's really simple. Let's have an expression 3 plus 4 and let's have a stack. Let's try to read the first token. If it is a number, then we push to the output. The next one is an operator. So add it to a stack. The next one, the next token, is a number. Add to the output. Now the input is empty. This means that we have to remove everything from the stack and push it to the output. So we have the result. Let's see another example. It's a bit more complicated. We have different operators and we have opening and closing brackets. So let's read the first token. It's a number. Add to output. It's an operator. The next one, add to the stack. Again, a number. Add to the output. Again, an operator. Add to the stack. Again, a number. Add to the output. Again, now it's an operator. So, because that operator has the same precedence as the previous one, remove the previous one from the stack, add to output, and put the new operator to the stack. Now we have an opening bracket, add to the stack, number, add to output. Now we have an operator, add to the stack, again a closing bracket. So we removed everything from the stack till the opening bracket, and then, because the input stream now is empty, we remove everything from the stack and we add to the output. So here we have the result. Now the big question is how to calculate the expression. So we have the original one. Now we have the one in reverse Polish notation. And now let's calculate it. We have a stack and we have the input. So a number, add to a stack, again a number, add to a stack, number, add to a stack. Now we have an operator. So pop the first two elements, 2 and 4, apply the operator. And we have to push the result back to the stack. Again, we have a number 1, add to stack, number 5, add to stack, and now we have an operator. Pop 5 and 1 and apply the operator. Put the result back to the stack. Again, we have an operator. Pop the first two elements and apply the operator and push the result back to the stack. Again, on the input, we have an operator. So pop the first two elements, -2 and 3, and apply the operator. And push the result back to the stack, because the input string now is empty. So we have the result on the stack. We pop the result to output. And this is the one. You can find example implementation on GitHub. Thanks for listening me. Bye.